If you remember from previous videos, we have learnt that the relative atomic mass of an element is the weighted average of the relative isotopic masses of its natural isotopes on the 12 carbon equals 12.00 scale. According to the carbon-12 scale, a magnesium atom has the same mass as two carbon-12 atoms. Its relative atomic mass is 2 times 12 equals 24. In previous videos, we can find the mass number of any element by looking in the top left corner of its nuclear symbol. Sometimes though the nuclear symbols will show the relative atomic mass. So whereas particular chlorine atoms could have mass numbers of 35 or 37, chlorine as an element has relative atomic mass of 35.5, because that's the average mass of these two isotopes, when we consider how common each one is. But what if we want to find the average mass of an entire compound, which will obviously have more than one type of element? For example, water and sodium chloride, that would be relative molecular mass, or relative formula mass, otherwise known as EMA. So we're going to talk about the differences between all those different terms, and make sure that you can calculate it by the end of this video. Let's have a look at water, or H2O. It's made up of two elements, hydrogen and oxygen. Hydrogen has got relative atomic mass of 1, and the relative atomic mass of oxygen is 16. I've got 2 hydrogen, so I'm going to times it by 2, and I've only got 1 of oxygen. If I add those two things together, I get H2O relative molecular mass, which is 18. You need to know about relative molecular mass has got no units, so the definition of relative molecular mass is the sum of all the individual atomic masses. If you've got something that's ionic compound, you can't really call it a molecule, so relative molecular mass doesn't really make a lot of sense, so instead we use relative formula mass. So if we took a sodium chloride, which has the molecular formula NaCl, we'd have 1 sodium, which has relative atomic mass of 23, and 1 chlorine, which each has a relative atomic mass of 35.5. So we'd do 23 plus 35.5, giving us relative formula mass of 58.5. To calculate the mass percentage of an element in a compound. For example, we could find the percentage mass of sulfur and sulfuric acid. For this we do the relative atomic mass of the element. We're looking for times the number of atoms of that element, divided by the relative molecular mass of the compound, and then we multiply all by 100, to turn it into a percentage. So here we would do 32, which is the relative atomic mass sulfur times 1, because there's only 1 atom of sulfur and sulfuric acid, divided by 98 as that was the compound's relative formula mass. This gives us 0.327, which we then times by 100, giving us our answer of 32.7%, before we finish. Let's find the percentage mass of nitrogen in ammonia, which has the formula NH3. The first thing to do is to recall our formula, and check the periodic table to find the relative atomic mass of each element. So 14 for nitrogen and 1 for hydrogen. So for the top of our equation we need to do 1 times 3, because we have 3 hydrogen atoms. Then to work out the EMA, we do 14 for nitrogen, plus 3 times 1 for hydrogen. So if we simplify it we get 14 divided by 17, which we times by 100, to give us 82.3. And that's all for this video, so hope you enjoyed it and we'll see you next time.